In this video, I'm going to show you how to find the intersection of a line and a quadratic. There are three cases for what might happen. The first case is that there can be 2 points of intersection. For example, in this diagram, these curves of the line and the quadratic parabola intersect at these 2 points of intersection. We can also have just a single point of intersection, where the line just hits the parabola as a tangent. And lastly, we can have 0 points of intersection, where the line and the parabola don't cross at all. Here's a concrete example of finding the points of intersection between a quadratic and a line. And so we're going to start off by writing a system. The points of intersection are just the solution to this system, y equals x squared minus x plus 3, and y equals x plus 2. So since we can have either 2, 1, or 0 points of intersection, we should expect either 2, 1, or 0 points of solution for this system. To solve this system, we can go ahead and set the y's equal to each other, and then we get x squared minus x plus 3 is equal to x plus 2. And then it just remains to solve the system, or the equation. We've got an equation with x and we can solve. So x squared, subtract the x from the other side, minus 2x, and then subtract the 2 plus 1 equals 0. This can be factored into a perfect square. X minus 1 squared equals 0. So taking the square root, we've got x minus 1 equals 0, which means x equals 1. And then we need to find the y-coordinate also, so we can substitute that back into this equation. So y equals 1 plus 2 equals 3. So the point of solution here is 1, 3. And this is the point of intersection of the two curves. Here's another example. It's the same idea. We want to find the points of intersection of this quadratic and that line. So we set up a system consisting of the quadratic, y equals x squared minus 2x minus 2, and the line, y equals negative 3x plus 4. And then to solve this system, we can set the y's equal to each other. So we get x squared minus 2x minus 2 is equal to negative 3x plus 4. Okay, now that we have an equation in x, we can go ahead and solve. So adding 3x to both sides, we get x squared plus x, and then subtracting 4 from both sides, we get minus 6 equals 0. And this quadratic also factors nicely. X plus 3 times x minus 2 equals 0. So we've got two cases here. We've got either x plus 3 equals 0, or we've got x minus 2 equals 0. If x plus 3 equals 0, then x equals negative 3, and then y equals negative 3 times negative 3x plus 4, which equals 9 plus 4, which equals 13. And then that means our solution for this case, our point is negative 3 comma 13. And then for this case, if x minus 2 equals 0, then we've got x equals 2, which means that y equals negative 3 times x 2 plus 4, which equals negative 6 plus 4, which equals negative 2. So the point corresponding to this solution is 2 comma negative 2. So these are the 2 points of intersection of the parabola and the line. Here's our final example, and we're going to deal with it just like we did with the previous ones. We're going to set up a system of the quadratic y equals negative 2x squared minus 3x, and the line y equals x plus 10. And then we can solve that system by setting the y's equal to each other. So we get negative 2x squared minus 3x is equal to x plus 10. Alright, now we've got our equation in terms of x, and we can solve it. So let's subtract x. We get negative 2x squared minus 4x, and we'll also subtract 10. So minus 10, that's equal to 0. To make this a little bit simpler to solve, let's divide by negative 2. So this just becomes x squared and plus 2x, then plus 5 equals 0. And this doesn't factor really cleanly, so we'll just use the quadratic equation. X equals negative b is 2, plus or minus root of b squared, which is 2 squared, minus 4 times a is 1, and c is 5, all over 2a, so 2 times 1. So let's simplify this, let's compute. So that's negative 2 plus or minus root of 2 squared is 4, then minus 4 times 5, that's 20, all over 2. So x equals negative 2 plus or minus root of negative 16 over 2. And now this negative 16, that's an imaginary number. So there's no real solution. That means there's no solution in the real numbers that we can see in the plane. So that means that there's no points of intersection. And that's our conclusion. These two curves, this quadratic and that line, they don't intersect at all. In the future, we'll also learn how to find the points of intersection of lines with other nonlinear functions, such as radical functions and hyperbolas.